So in this video, we're going to learn how to solve exponential equations using logarithms. Now you're going to have to do this anytime you're solving an equation where your variable is in the exponent. And the key thing is to be able to turn expressions like we see here on the left into expressions that look like the one on the right there, okay, the log form. And then we'll use technology to actually get an answer and use a approximation if we have to. So again, I've got a little table here just to remind us of how you can turn exponential form into log form. And I'm going to copy this box onto every single problem we do just to remind you how to do that. But in any case, look below and see that we have a variable in the exponent in every single situation. To turn this into log form, you need to basically focus on the right-hand side of this equation. And note that we've got log base b of c equals x. That is equivalent to the expression, or the equation rather, b to the x equals c. So, just as a reminder how log form works, remember your base is down here, b to the x equals c. That's sort of the flow that your brain should do to check that you've correctly translated exponential form to log form. So we can see in every single case down here, I've done that correctly, right? So 5 to the x equals 25. 5 to the x equals 25. 2 to the x equals 8. 2 to the x equals 8. 4 to the x equals 20. 4 to the x equals 20. 10 to the x equals 22. Again, remember by convention, the base of a log that has no number below is 10. So this really does mean 10 to the x equals 22. And then, of course, ln is what we write when our base is e. So you can write it in if you want. E to the x equals 17. Okay. Now notice in each of these, in the middle column, I've successfully solved for x, right? But I want to put down some numeric values, and to do that, we'll probably need a calculator. So we're going to take a moment and talk about the ways you can evaluate log expressions in a calculator, especially when the base is something other than e or 10. So let's do that right now. So for instance, we want to evaluate log base 4 of 20, the one here in the middle. Okay, so that would look like this. So I'm going to do this problem here. So let's take a look at our options for doing that. So first of all, if you're using Desmos, you can do this by, so just again, a reminder, we're trying to evaluate log base 4 of 20. So to do that, you can click on this keyboard down here. Okay, that brings up some options. You don't see the log button. You have to hit functions. And then there's a few like tabs here. You want to go over to miscellaneous, the one that says log with the little a below it. That allows you to choose the base. We want our base to be 4. So I'm going to put a 4 there. I'm going to put a 20 here. And we get our answer. Let's round this to hundredths, 2.16. Okay. So when I write the answer down, that's what I'll use. The other thing you can do is just by keyboards. I can write the word log. And now if I hold shift and underscore, it brings me downwards. I can put a 4, hit the arrow over, and put a 20 there. You get the same thing. Okay. And then lastly, you could use delta math. So if you're using delta math, you click on this keyboard here. Unfortunately, there's no button where you can choose a base, but you can use my keyboard shortcut. So I can type log. I'm going to hold shift. Okay, that brings me down. I'm going to type in the number 4. I'm going to press over, and I'm going to put a 20 there. And that successfully evaluates our log. Okay, 2.16. Now, if you are in a situation where there's no way to choose your base as we did here, so for instance, if you're in the Desmos scientific calculator, unfortunately, you have to use what's called the change of base formula. Okay, the change of base formula. So let me do it on this screen here just to remind you what that is. So the change of base formula says you can find any log you want. So if I just hit functions, and let's just pretend the only buttons I had were these, this log and ln. I'm just going to type the word, I'm going to put the word log there. that 20 is going to be my first input, so I'm going to put 20. And then I can divide that answer by log of the number that's below. Okay, that's called the change of base formula. So obviously, if you're using the graphing calculator display, it doesn't matter what you do, right? They're all producing the correct answer. But if you're in a scientific calculator, then you'd have to use the change of base formula. So in this case, I would write log 20. I'm going to go over. Oops. I'm going back to main, divide by log 4. Now you can see I tend to use the keyboards as much as I do the buttons, but depending on if you're using a Chromebook, sometimes it's just easier maybe to click. In any case, 2.16. Okay, so we write our answer as 2.16. Let's do log base 10 of 22. So again, that's the base already is, I'm actually going to just default now to decimals. I kind of prefer it. So I'll delete these. So log base 10 of 22, because by default log has a base of 10, you can just write log of 22. Okay, and that gives you 1.34. And while we're at it, we'll do ln of 17. So you can type ln, or you can just click this button here, ln of 17. So I'm going to write 1.34 and 2.83 for my answers. Okay, let's take a look at an actual exponential equation, and we'll start to kind of build from the simplest case to the more difficult cases. The key again is turning exponential form into log form. Okay, so I took this problem right from Delta Math, and it says solve for x rounding to the nearest hundredth. So that'll be sort of the last thing we want to look at, right? We don't want to get a problem wrong because we didn't round correctly. But it says 2 to the x equals 3. Okay, now this problem is not conducive to guess and check. But if we were to do that, notice that 2 to the 1 is equal to 2, and 2 squared is equal to 4. So we sort of missed the answer, right? We wanted to get out a 3. So 2 to something is supposed to equal a 3. And if you take a look there, it looks like that something's got to be a number in between 1 and 2. Probably some decimal in the middle. So let's just keep that in mind as we do this problem. But I need to turn this exponential equation into log form. So I'm going to write this problem in like this. I'm going to say log, I'm going to put a box here for my base. I'm going to put a box here for what's called the argument. And then I'm going to put put another box here. And the reason I'm doing that is because I want you to really get into the habit of this type of motion. B to the x is equal to c. That is stating exactly what this says on the left in words. So now I need this log expression to read 2 to the x equals 3. But that must mean the 2 goes here, the x goes here, and the 3 goes here. Because 2 to the x is equal to 3. Now we are done essentially. I mean, this is the answer, log base 2 of 3. But as I said, we're going to need a calculator because, well, for instance, they wanted us to round our answer to the hundredth, so they want an approximation. So log base 2 of 3. So I'm going to go here. I am going to write the word log. I'm going to hold shift and underscore log base 2. I'm going to press over. I'm going to type 3. Now I'm going to write out kind of a lot of decimals just so we can remind ourselves about rounding. 1.58496. 1.54. Say 1.54. I'm sorry, it was 1.58. Try not to memorize there. 1.58496. We want to round to the hundredths place. A reminder, the hundredths place is the second number after the decimal. So we underline that, tenths, hundredths. This is the hundredths. You look at the number to the right of it. If it's 5 or more, the 8 becomes a 9. Otherwise, it stays an 8. That's a 4. So we round down. 1.58 is our answer. And that is what you would type into Delta Math to get this problem correct. Okay, so we have to express an exponential into log form, correctly evaluate it into the calculator, and then round correctly. And notice, just as a little sense check, right? 1.58 is in between 1 and 2, so that suggests we did this correctly. Let's try another one. This says, solve for x, rounding to the nearest hundredth again. 6 times 10 to the x is equal to 1. Now, the first thing you should notice is we don't have our exponential expression, meaning the base, isolated. We need that 10 to the x to be alone if we are to use this relationship here. Okay, so we've got to take care of this 6 over here. 6 is being multiplied by it, so to undo that, I need to divide by 6. So now I have the equation 10 to the x is equal to, I'm just going to leave this as 1 over 6. And now I can clearly see what my base is. My base is, in this case, 10. Okay, and I can just follow the conversion here. So I'm going to write, as I did before, the word log, put a blank for the base, a blank here, and a blank here. And I'm going to read this equation in words. 10 to the x equals 1/6. So that must mean the 10 goes here, so that 10 to the x is equal to 1/6. And now I evaluate this on a calculator. So now you could remember that log base 10 is by default in our calculator, it's just the word log. But it's not incorrect just to, you wanted to be sure, hold shift underscore log base 10, 1 divided by. Now, notice what happened there. That's not what I want. I wanted the 1/6 to be in the entire interior. So I have to insert some parentheses there to get my answer. So I'm going to jot down this answer. I'm going to just remind you how to round correctly in a minute, but I'm going to do more than I need. So negative 0.7815. Okay, that's way more than what we needed to do for our rounding, because it's at around the nearest hundredth. So let's remind ourselves how to do that again. The second spot over is hundredths. So this is the hundredths. I will examine the number to the right of it. That is bigger than a 5. So that 7 I underlined needs to become an 8. So negative 0.78 is equal to x. All right, let's move to one even a little more complicated. So this equation says e to the 2x is equal to 2. And again, I'm rounding to hundredths when I get my final answer. Okay, so notice this time I don't have a number in front, right? If there was like a 5 here, if there was like a 5 here, okay, the first thing I need to do is divide by both sides by 5, like we did in the last problem. That's not the case. So I can immediately express this relationship in log form, okay, because I have my base isolated. The e is the b in this case. Okay, my e is my b. So as I did before, I'm going to write the word log blank blank equals blank. I'm going to read this equation in words. E to the 2x equals 2. So if that's the case, this must be an e to the 2x is a 2. Okay. Now, I still haven't solved for x, right? The right side of the equation now says 2x. I'm trying to solve for x, so I'm going to have to divide both sides by 2. But before I do that, let's just remember that log base e is more conventionally written as ln. So I'm going to just rewrite this as ln of 2. ln of 2 is equal to 2x. And the last thing to do to solve for x would be to divide both sides of this by 2. And I go punch this into the calculator. So ln of 2 divided by 2. So you can write ln. Again, maybe I'll just use the keyboard for this one. Again, if you had functions, go over to ln here. ln 2. Make sure you get out of the parentheses to perform dividing by 2. And this is what we want. So 0.34657. I'll write all that out. 0.34657. That's equal to x. And now I do the rounding. I'm supposed to round to hundredths. That's the second decimal place as usual. I examine the number to the right of that. That number is a 6. That's 5 or more, so that must mean I need to round that 4 up to a 5. 0.35 is what I'm going to plug in. Is what I'm going to input into Delta Math. And I just realized I was not on the right screen there. All right, so this gives you an overview of solving exponential equations, basic exponential equations using logarithms.